Hey everybody. I think I've messed around with the microphone levels, so hopefully this will be a little bit louder so you don't have to crank the sound quite so much. Anyway, we're going to talk about 3-4 and graphing. I know a number of you guys are out today, so hopefully this will be helpful. For those of you double checking stuff, the examples are going to be a little different than what you see in class on purpose. So then that way it's not quite, just a peer review. First thing we're going to talk about is general shapes of graphs. Interestingly enough, if you look at the degree of a polynomial, and we'll do a quick little example of what one would look like, and then we'll talk about general shape. So obviously if you have degree 1, that's linear, so you get like, 2x minus 3. You should see something and say, oh, that looks like a line. Much like, and we've graphed this early in this chapter, so you get something like that. So it will look like this. And now remember, again, if that leading coefficient is negative, it's going to invert everything. If I look at third degree, you get y equals, whatever. And you can have, 2x cubed minus 7x squared plus 6x minus 11. Now the interesting thing here, what you'll end up doing is that when you start getting cubic, you'll notice it'll go like that. And if you think about what's going on in the graph here, if I put a very large negative number in here for x squared, like, negative 10, negative 100, you're going to get a very large positive number out. So it does kind of make sense that over here, it's finishing going up. Likewise, if I plug in a very large positive number in for x squared, I'm also going to get a positive number coming out, so that's why that's ending up here. But like, with the cubic equations, if I plug in like a negative 100, this is going to happen here. That's going to be the most influential, because a negative 100 cubed is going to be bigger than a negative 100 squared. And that's why it eventually finishes going down. And likewise, a positive number doing that is going to finish going up. And so you're going to see this pattern back and forth with your, you're going to see this pattern going back and forth in terms of the degrees. So like fourth degree, 4x to the fourth, blah, 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 plus other stuff, you're going to get something that looks like that. And in actuality, the degree, if there's unique, well, not just unique, but with a couple of exceptions, what will end up happening is that you'll have the degree will talk about how many different directions you're going. So here, if I were to draw this, I'm going down 1, up 2, down 3, up 4. And that would give you the 4 different directions. So a fifth degree polynomial would have to go in 3 different directions, or 5 different directions, I'm sorry. So fifth would look like 1, 2, 3, 4, 5. Now again, there's some potential changes in there. If you have roots with multiplicities of more than 1, that can make a change the effect and things like that. Upshot of this is the following. Okay, the coefficients, or leading coefficient, determines end behavior. Okay, think slope. It's slope-like. So if it's bigger than 0, so if it's positive, okay, it's going to finish positive. And that's like what's going on up here, because again, 4x to the fourth, if I plug in a large positive number into that, it's going to stay positive. If it was negative 4x to the fourth, then the coefficient is going to flip everything. And like we talked about before, that leading multiplier will invert things and flip things upside down. Likewise, if your leading or your coefficient is less than 0, it's going to end going down. Okay, and that's because it inverts it, just like a parabola. Now, if you look back up here real quick, notice what's going on in terms of my odd degrees. Those end in opposite directions. Because again, think of it as a line. If you have a positive slope, it's starting negative and it's going positive. And if you have a quadratic, or you have something that's quadratic-like, so anything that has a degree 2, a degree 4, etc., if it's even, you get this thing here, just like what we talked about. Because again, if I put in a big negative number here, it's going to turn out to become positive, because a negative number to any even power is going to be positive. So if the degree is even, or it can be odd, they go opposite ends. Opposite end behavior. And since you already kind of know what's going to happen, I'll do an example or two, but since you know what the ending is going to be like, so if you know what the beginning is going to be, and if the degree is even, then the opposite behavior is the same. It's not opposite behavior. The end behavior is the same. Okay, so as an example, let's say I had negative 3x to the 6th minus 7x to the 3rd plus 6x squared minus 4. Okay, and I just wanted to know the general shape of this. This leading coefficient right here being negative means it's going to end down. This, since it's even, you're going to get the same direction. So that means it's going to start, since it's ending down, that means it's going to start from down. And actually, if you want to do the shape, now we have 6 different changes of direction. So you go, okay, it's starting from here, going up 1, 2, 3, 4, 5, 6. And you kind of get this wave function. Now, obviously, the waves can be different heights and all that other stuff, but that's going to be the basic of what's going on. Okay? Now, in practice, what you're going to end up doing when you graph this, we're going to actually use the calculator for a vast majority of this, because, again, you know how to do stuff by hand. We want to get to the fun stuff. Okay? 4 steps to graphing these things that you need to know is you need to say, okay, first of all, let's take a look at general shape. Because even if you're using a calculator, you need to be able to say, wow, I'm doing that right, or I'm doing it wrong. Okay, so the general shape, you need to say, all right, that's what I'm expecting. Much like if somebody brings you a dessert tray, you're going to expect, oh, I'm going to get something sweet. Okay, if you're not seeing that, maybe you're in the, at the salad bar. Zeros of the functions are very important because those are going to be the x-intercepts. You need to find values between the zeros. Now, traditionally, if you did this the regular way, when you were testing to find zeros, remember, all of the remainders that aren't 0 are your y values. So you find points to go through and plot. And then obviously graph it. You better know how to graph points at this point of your math careers. Okay, so let's actually do one. This first one is going to be a basic level problem. The reason why it's a basic level problem is because it's already factored for you. And so this right now, you know, is going to be degree 3 because you have 3 x's in it. So again, general shape. So we're degree 3. The leading coefficient is bigger than 0, so we know it's going to do something like this. For 2, my zeros, you should be able to pull right off your equation. So zeros are going to be at 1, negative 2, negative 3. So when you're plotting this out, now the one thing to also remember, well, hold on, let's do this first. Make your axes. Label your axes. When you're using intervals and stuff, I would, like in this case here, so here's x, here's y. We know that we're kind of counting by ones over here, so we're fine using this because our zeros are not that far apart. I wouldn't label my y-axis yet because we need to see how far up and down we can do it. Because again, obviously, the higher degree you're having, the higher power you're having, and you're going to be taking some of these numbers. I mean, even 0 and stuff are going to be fairly high. Okay, so let's put our points in. So we're going to have a point here at 1. We'll have a point here at negative 2, and we're going to have a point here at negative 3. So we're going to get like a little blip there. Now, if we're doing this right, I'm going to grab the magic pen quick. We should see something coming up from up here, coming back down, and then coming up through here. Now, you can't just do a halfway graph like that. Okay, you need to make it somewhat accurate. We need to come up with a good y-intercept and all of that. But the interesting thing here is that once we get outside, I don't want green, I wanted the magic pen. Once we get outside the zeros, it's going to get very extreme very fast. And all of the interesting stuff happens between the zeros. And that's actually, if you're going to use these as modeling for situations, that's usually where the fun is going to happen. So now what we can do is we go to our calculator. And I'm fine with you doing this because now, again, normally what you'd end up doing if you didn't have a calculator, you'd pick points between the zeros, you'd plot them up and go from there. It shouldn't be that hard to do. But I'm, as I said, fine with, so we want to make sure that we come up with, you know, be able to do some fun problems instead of just sitting around waxing nostalgic about how life was done in the 80s. Okay, so if we graph this, first of all, just to verify that we've got the right information, that's exactly what we expected. If we go to our table, we can find, hopefully, a window that's going to cover all of our points. So let's see, one's our biggest one. There we go. So we don't have a point that we're going to get between -3 and -2, but such is life. Now notice here, the extremes are going pretty high. Okay, if you can plot it, fine. If not, you can just make sure it runs off the graph. So -4 is going to be down here at 0. Obviously, we're going to go up. The closer the zeros are, the less room there is to get high up off the axis. So we know we're going to be somewhere up here and there. If you want to plug a point halfway in between, that's fine. If not, I can live with that. And so then we've got -4. Oh yeah, here, let's make sure we label, put in our scale. Oops. No, that was right. Just the way this pitched. Okay, so then that, we have -6, coming back up to 0, and then we're already way up here at 20 by the time we get 2. Now when you graph this, no, don't, ooh, straight line, look, I can connect dots. No, you're better than that. I want nice, smooth curves going through. Okay. Now again, that's basic. You need to be able to find your own zeros on your own. And I'll show you that in the next example before I turn you guys loose. So in this one here, again, if you notice, from here, the shape, since it's positive, it's going to end going up. Since it's cubic, it's going to get this 3 thing here. And it is a little goofy because you are kind of working backwards when you're drawing this, but you kind of get an idea of what's going on. For my zeros are possible, it's going to be obviously, you get plus or minus 1, 2, 3, and 6, and then you also have to divide those all by 2, so you're also going to add in plus or minus 1/2. 2 halves I have, 3 halves I don't have, and then 6 halves I have. So those can be one of those 12 numbers. And again, you can have the calculator there. I'm going to expect that you could go through and do this if I need you to do it, or if I ask you to do it. So, you know, don't be all, if I end up doing that. But to get an idea of which integers are, we're going to have, and actually since the fractions are halves and there's no thirds, it should be pretty easy to tell which ones are falling right down the middle.